Come on in.
It's been hard.
I'm so worried.
You'll do good.
Trying.
To graduate this semester. Thank you. If I get everything done, it's lacking.
Yeah. Kids are
I just feel like I'm kind of like burned out.
I know the feeling.
What?
Okay, so everyone, can you see the slides online? Awesome. Let's see if this works. I'm trying a different configuration. I can see your comments and I can work out with the slides. So, so let's say we wanted to let's say we wanted to. Hello. So let's say we wanted to do the same task over and over again. Right now, you'd have to copy and paste over and over again, and that would be kind of not very useful. So what we're going to find out today is that there are some constructs, there's for loops, and there's while loops that we can use to repeat expression or code over and over again. So a better approach than writing code where you say send mail, wait 1 month, send mail, wait 1 month, send mail, wait 1 month. You have this continuous loop. And in fact, there are actual programs, for example, the services that run in the background of Windows are actually just infinite loops that just run in the background. And mail is actually one of them. So a better approach would be if we could say something like, while we aren't stopped, let's send mail, then we'll wait 1 month, and then we'll just keep repeating that. So let's try this. Let's write some code, make a program that says x equals 1, and while x is less than or equal to 100, print x, and then we will increment x by 1. So x plus equals 1.
Still trying to
yeah, so we'll take a few seconds to load up.
But I'm kind of familiar with loops because of the
C++ or?
No, IoT.
Oh, yes.
Yeah.
Yeah, you use those probably a lot. And so
Yeah.
you have and actually the IoT program is really a while loop that just runs continuously.
Yeah.
Yeah, it's a while true.
Yeah.
And then you're looking at sensors and then
Exactly.
making decisions and then it goes the opposite way and then you chase the robot around or yeah. Right on. So let's see you next time. And let me know if you wanna meet, and then we can go over the stuff. My office hours are usually between between 3:30 and 5:30 on Wednesday. Let me know if you have availability in there, and we can meet then to go over stuff. Or
Friday would be better.
Fridays after between 10 and 2. Okay. I'm usually at Hackerspace.
Okay,
thanks. So okay, so we've got this loop, and if you run this, you get 1 through 100 displayed. Yeah, and so if we look at what it did? It started off with x is equal to 1. Let me see. Will it let me mark? So, we start off with x equals 1, and then is 1, then you look here, is 1 less than 100. So that, with that while statement, this area right here is almost like an if statement, except that instead of just executing one time, as long as that expression is true, it'll keep doing this block of code here over and over again. So here, when x equals 1, 1 is less than 100, so it does the block of code. It will print, 1, and then we have this line that increments x, and so that becomes 2. And then we come back around, and then we ask ourselves, is 2 less than 100? Well, 2 is less than 100, so now it does the print statement and prints 2. Adds 1 to 2, which becomes 3. Then it looks and sees if 3 is less than 100. And so then it just keeps going on until it gets to the end. Now, at one point, x becomes 100. 100 is less than or equal to 100, so prints the 100, adds 1, and x will end up being 101. And when it does that, 101 is not less than or equal to 100, so that's why it stops right at 100. Does that make sense? Does that make sense online? I just got to figure out how to. Okay, there we go. Back to my slides. So now let's try another program. And this one, what we're going to do is we're going to start off by setting name equal to an empty string. And then we're going to do another while. And it says not name. And while not name, we're going to input, please enter a name. Where am I? Sorry. There we go. And when you get done, run that, and what you'll do is you'll put in a name, and it'll work. And then try not putting a name in, just hitting enter. Where it says please enter a name, just hit enter and see what happens. Yeah, and this is what we call holding the program or the user hostage, because it won't exit out of this loop until you provide a name. And the reason is right here. Right here, we say not name. What does an empty string evaluate to when you treat it like a Boolean? It's false, right? Zeros or empty strings evaluate as false. So the way this works is, yes, correct, Brendan. So the way this works is while name is empty string, it'll keep asking the user to input a name, and then eventually, oh, how's it now? Is the mic okay? So I may just raise my voice a little bit. So as the name, if the name is an empty string, it's going to keep looping through until the user enters something. You'll see this pattern actually quite a bit. You'll see if not, like you're trying to read something from a file, and it checks to see if it says if line, then it continues on. If you get nothing from the file, then that's how it knows that the file is ended. And so using the Boolean equivalent of those implicitly is a common pattern. So let's try another one. And this is one that you're going to use quite a bit. So I recommend actually keeping this, this piece of code handy. What we're going to do is we're going to start off by declaring a variable called doAnother, and we're going to initialize it as y. And then you're going to have a while statement that says while doAnother equals y, and then we have a block of code. And for in this example, we're just printing do some stuff. Imagine that whatever program you have done in the past, you actually had all of it embedded in there. And at the end of it, you would ask, the user, do you want to do another? And if they would enter a y or an n. So if they enter a y, what will happen is it'll go back up to the while, do another will still be y, and it'll keep looping through. As soon as they put anything other than y, it'll drop down to the print, thank you for using my program, and then stop. Is anyone else getting mic issues? So it's loud right now? I might have had my hand over the microphone. So when you get it, run the program and just keep hitting Y for a little bit and see if it keeps looping around, and then hit no and see if it stops. Does that work?
Yeah.
Does that work online? Yes. So that do another loop for console-based applications, it's almost ubiquitous. In fact, if I'm going to make a console application, I'll start off by writing that piece and just say, do you want to do another yes? Do you want to do another yes? Do you want to do another yes? And then no. And make sure I've got my loop working, and then I'll put my code in. And one of the reasons I write that first is because then it's easier to troubleshoot, right? I can run the program multiple times and test it out rather than having to hit run every time. So you put Y, it'll do some stuff again, you put no, and then it'll stop, and then it drops down to the last statement. One important thing with loops is looking at your tabs. When you're first starting, you may not get your tabs exactly right in your blocks of code with Python especially. Even experienced programmers that start doing Python for the first time haven't used tabs to indicate blocks of code. They get them all out of line, and it gets into a mess. And then if you stay neat, it works. It doesn't work too badly. Okay, so those were all while loops. And the thing about while loops is they're like if statements. It's just that if it's true, it'll try again. And so an if statement basically executes one time. A while loop will keep looping until you have the condition becomes false. What happens if in your while loop, nothing ever makes the condition become false? It'll keep looping until you get an infinite loop. So if you run your program and it just seems to hang up there, one of the things you want to look at is, hey, what makes this condition, actually go and become false at some point? And one thing you can do is, you put a little print statement in there to print temporarily to print out variables that you want to see what the values are, and you'll see them. You might see them keeping climbing and increasing and never get to what you think it's supposed to be, and then you'll say, oh, okay. So that's a while loop. While loops are nice because they're very flexible. But there are instances where this other type of loop is helpful. So try typing this one in. We're going to make a list with this is an X parrot from a Monty Python skit. And we're going to make what's called a for loop. I'm going to try to change the way this one's executing so I can write on it a little bit more easily. So when you run this, you should get each of the words one after the other. Does that work? Does that work online? The for loop is sometimes confusing to people because right about here, this word right here is, or this variable right here is kind of confusing to people. So what that is we say word for word in words, word will take each element of words and take its value on one at a time, and then you do the block of code and then come back at the next word. So initially this goes into word. So if I was to keep track of what's going on, word would equal this initially. And then for my output, it would print word. So then I get this. Then I come back around the loop and it takes is and puts it into word. So now word is, and I get is. Then I come back around and goes into word. And I get the and with the print. Then I come back around and X goes into word. And it's boring at this point, but this is where people get kind of confused with what this variable is. With the print. So think of this variable right here as basically a temporary holding place, which is going to take each element of the sequence over on this side and will take its value one after the other and then execute this block of code down here. Does that make sense? So if you haven't seen a for loop like or for each type of loop in another language, that can be confusing. So here's another one. Let's say that we wanted to do stuff with numbers. You can make a new program if you want, or change the existing one, but make it numbers equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and say for number in numbers, print number. And I kind of like this way of doing the variables, where my sequence is plural and then my loop variable is singular. So when you run that, you get 0 through 9. Does everyone get that? Yeah. And so let's say that we wanted to, write out 100 numbers. So go ahead and change your code so that you write out 100 numbers. Okay, you got to be thinking as a programmer, we're not going to be doing that, right? That'd be ridiculous. So try this. Say range 0, 10. And then you get the same list that was in the top before, right? So we have the same list that was right here. Ends up when we do range 0 through 10. Make sense? So that becomes a shortcut, and we could, and then if you said, just try saying range 10 and see what you got. And in that format, again, we get 0 through 10. So if you only specify, if you specify 2 numbers, it goes from the beginning one to the end. Does it go all the way to 10? So it's still that same pattern, right? Inclusive, exclusive. And if you just put 1 number, it'll assume that you want 0 for the first number. And it'll just automatically do that. So change your code so that it says this, for number in range 1, 101. Print number. And then try to predict what the last number is that's going to be displayed. So what number do we think we're going to get last? What do you think online? Yeah. Because again, inclusive, exclusive, with ranges in Python means that the last number isn't displayed, it's the one just before. And if you run that, you should get all the way to 100. A lot easier than writing out a list with 100 numbers in it. So those are your main loop formats, the while loop and the for loop. Of the two, the while loop is the most flexible. You could actually do kind of the same thing, displaying X number of numbers with a while loop. But we typically will use a for loop, and I'll ask you to use for loops when it makes sense and while loops when it makes sense, and not try to make one do what the other does. There's certain instances where you'll find where one loop will do better. Here's an example of using a for loop over a dictionary. Let's try this. Let's make this a dictionary, and we have 3 keys with 3 values. X will correspond to 1, Y will correspond to 2, Z will correspond to 3. And just as a review, remember that a dictionary is basically a sequence of key value pairs. And so the first element on the left of the colon is the key, and the one on the right is the value. And then we're going to say for key and D, print key corresponds to, and then we're going to have the dictionary name and use square braces and pass the key to it to get the value. So put that together and run it. And when you run this, you should get X corresponds to 1, Y corresponds to 2, and Z corresponds to 3. And basically what's happening is, what we're getting out of here is X will go into key, and then we use that key here. When you say D open square brace key, it'll get back the 1. So that's why we get, this gives you the 1, and then the key just displays right there. And then as you loop through, it goes through each one. Does it kind of make sense how it's taking advantage of the dictionary? But there's another way we can do this. We can actually, and remember we talked about sequence unpacking before. Since dictionaries are a key value pair, so that's the key and that's the value. If we do for key comma value in our dictionary, and you say dictionary.items, dictionary.items will return basically a tuple with the key and the value in it. And so we're taking, the key will go in here and then the value will go in there. We can do the same thing, and it's a little bit more, it's a little clearer perhaps down here how this all goes together. Because now rather than d.key to get value, we just put in value. Does that make sense? So try that one, that change, and see what happens. And it should basically get the same result. But that's referencing the items method of the dictionary class and the sequence unpacking. So you can so Python, it's kind of neat. You can put two things on the left side of an assignment and you can get things out of a sequence. Does that make sense online? Cool. All right, so at this point, I think I'm going to pause and I'm going to go look. We're going to look at the next spec because we have enough for that. I have it open. Can everyone see the spec? Oh, probably not now. Okay, so we're going to write, this is going to be a little bit more complex than the things we've done before. We're going to make a rock, paper, scissors game. And actually ignore this line right here. I'm going to take that out. And I'll re-upload that spec. So basically, what you're going to do is you're going to start a game of rock, paper, scissors with the user. The user will play against a computer. A scissor can cut paper, a rock can knock a scissor, and paper can wrap a rock. So we're going to do this in a do-while loop, and or a while loop in Python terms. So that way the player the game will play basically until either the user or the computer has won twice, and then you're going to give the user the opportunity to choose to play another series of games. So basically, so it'll keep going as soon as so you'll actually have a while loop inside of a while loop. The outside while loop is going to be like the do another loop. The inside while loop is basically going to keep track of how many times the computer's won, how many times the player won, and then as soon as either one of those has won twice, then it'll break out of the loop and drop down to the do another loop. And inside the play loop, what you're going to ask the user is, do they want rock, paper, or scissors? And after the user has entered his or her choice, the program will use a random number generator and make its choice. So we're going to learn how to use a random number generator in a second. And then your program will evaluate who won or if there's a tie. the program will report what the player chose, what the computer chose. Well, actually, at this point, the player knows what they chose, so you really just need to tell the player what the computer chose, and then who won that round. And then it will increase the tallies for the player wins and the computer wins, and then it will display the number of rounds that have been played so far, the wins and losses for the player and the computer, and then the number of ties. So if it's a tie, you're going to keep track of that as well. And then it'll just keep going around until you've won twice. And then after that, if after someone's won twice, then it'll ask you want to play another series of games. And when you're done, you just display a goodbye message. So the one thing we don't have yet is how to do a random number. What's that? Yes. And down here, I give you, here I give you an example of what the gameplay looks like. Welcome to Super RPS 3000, the best rock, paper, scissors game in the world. You know, it's good to put good marketing stuff on there to get your game sold. And then, you know, it asks for rock, paper, scissors. The player puts rock. It says what the results are. It how many with the score is 1-0, and then it keeps playing. And at the end, we have it looks like the computer wins, and it asks if you want to play another one. If you say no, it'll stop, and then gives us that thank you message. Your decision-making block is probably going to be an if, elif type structure. Now, there's many ways of doing it. The brute force method is you write down every possible combination of computer wins and player wins in this giant if, else, if structure. If you have to do that, I'll take it. But really, if you think about it, you could actually do this with an if, and then with ands and ors, write out all the conditions that would result in the player winning, and then you would say, congratulations, player wins. And if the player doesn't win, who has to be the one that wins? The computer, right? So then the default would be the computer wins, and that way you could do it with an if else almost. Well, also there's ties though. So really you probably have an if all the player conditions, else if or elif all the computer conditions, and then the final else would assume it'd be a tie. You could also maybe decide that the tie is easier to figure out, so you might make that your first condition you check all the player conditions, and then make the else be the computer wins. So there's different ways of doing this, and so you'll have to figure out how to structure this elif. So it may not be 50 cajillion elif statements. It might just be one with an else. Don't forget your indentation on this. You're going to have lots of indentation because you're going to have a loop within a loop with an if statement in there, and so you got to make sure your indentation is set up right. And here's how here's an example of using random number generation. So I'll open up idle here. I'll try this out. So if I import random, and then if we just look at random.rand range 3, and if I spell it correctly, I get a 0, and then I can execute it again, still a 0, then finally I get a 1. What do we think the range is that we're actually getting out of this? 1 to 3 or something else?
0 to 3.
Yeah, 0 to 2. So so we could do things with that. For example, if I had a list, options is equal to rock, paper, scissors. I misspelled it. Then I could say, if I said options of random range 3, it would randomly select from the string. And there's different things you can choose to do with this. The way you set it up, you might keep track of the number for the computer. You might just keep track of the string. You're going to have to be careful when you do your logical expressions that you're comparing strings to strings and numbers to numbers. So you might have to do some translation like that. But so one approach could be I'll just keep it all as numbers, and then when I display it, I will just pass it to the list and then get the value back. Or I'll just keep track of this. I'll just get a random string out of it and do it that way. So however you want to do that, you can. There's also other options in the random library. If you go look up the random library, you can actually set it up so that you pass it a sequence like a string, and it'll just randomly grab something from it. So if you want to use that, that's another option. But using that, that's how you can get the computer's choice. Does that make sense? Does it make sense online? So I think that gives you everything you need for this program. Don't do initialize an empty list, which we'll use to store the results of each game. I had that in a previous iteration of that, and I need to get rid of that from the spec. Other than that, does that spec make sense? Does it make sense online? Cool. Then I'm going to continue on with what's in this presentation. There's some neat libraries out there. One of them is the web browser library. So try this, import web browser, and then say webbrowser.open new wwcnm.edu, and you'll see that it opens up the website and returns true. So this can be kind of a neat thing, like if you're at work and there's certain websites that you constantly open, and there's about 5 or 6 of them that they've hired you to take information from one and type it into the other. You could actually use this to automatically open websites. Also, it's often used for help files. So some companies will put the help files for their application online, and then your application can actually use this web browser library. We're going to use the web browser library later on to do screen scraping, but this is just kind of a preview of what's there. So it's kind of a fun thing to play with. That work for everyone? And let's see, do I want to do this? Relation utilities, I don't think I want to get into that. Oh, this I do want to get into. So the next thing we're going to look at is the break. And you may need to use this may be handy to use in your program. Often, depending on how you structure your loops, you may not need this. But let's say that we wanted to find in this case, I think we're going from 99 back down to 0 and -1 increments. And notice that the range allows you to go backwards. So we're starting from 99 and we're going to 0. Are we going all? Do you think we're all going all the way to 0? No, right? Inclusive, exclusive. So we're really going from 99 to 1, -1 steps. This is going to get the it's saying take the square root of n, and then if root is equal to the integer of root, what does that tell? What does that mean? It means that we have an even root, square root, right? So 4 would return true because square root of 4 is 2. 2 is equal to the integer of 2, but like 5, the square root of 5 is 2 point something or other, and it would not there. So we're finding the first even square root of the number less than 100. And if we find it, we're going to print it out, and then we're going to break. What the break does is basically whatever loop you're in, break will actually halt the entire loop and go to the line of code after the loop. Does that make sense? So run this, and you should get 81. Do you get 81? So basically, 9 times 9 is the first even square root of a number less than 100. 9 times 9 is 81. So that's the first even root that you get less than 100. And these are kind of like some math questions that you could imagine being asked, and you can use loops to do it. But the main thing from this is notice how when it got to 81, it met the condition it needed, and it hit break, and then what it did is when it hit break, this actually exits the entire loop and stops the loop. So sometimes you may, if you're searching for something, once you find it, you store that variable and you hit break, and then you don't do the rest of the loop in order to avoid useless searches. Does that make sense to everybody? Oh, Antonio, you asked about yes, you can call APIs for using probably that web library or maybe some others. So if you wanted your program to ping an API to get some data back, you can use Python to do that. Okay, so now let's try the other variation of this is the continue statement. Unlike the break statement, continue doesn't actually stop the loop. What it does, it just goes on to the next iteration of the loop. So in this one, we're going for x in range, so we're going from 0 to 29. And what we're saying is if the modulus of x and 3 equals 0, we're going to continue. And what that means, it's basically going to skip every bit of code in the loop after the continue statement, and it'll go and pick up the next for loop, the for element. So what is this code going to do? Try to visualize what it's going to do and then run it and see what you get. So what do you end up getting? Yeah, so basically it's skipping anything divisible by 3. Because 3 mod, anything that's divisible by 3 that you take the mod of 3 will equal 0, and it hits the continue. And what the continue does is basically it does this. When it hits continue, it goes back around and picks up the next thing rather, and then so that would cause it to skip the print statement. Does that make sense? So continue says go to the next iteration of the loop. Break says completely stop the whole loop. So with the while loop, with the do another, what we did is we wanted to execute one time and then from then on check to see if there's a halt condition basically. And the way we did that is we preloaded do another with the Y and then it ran through. But on occasion so you could either make it so that essentially it does the process and then checks a condition, or it checks a condition before it does the process, and that works fine with a while. But sometimes you want you want to stop the loop in the middle of the loop. So let's try this. We'll say word equals dummy, while word equals input, please enter word, print the word was, and then it hits it. And notice that the initial value of word doesn't matter because we're going to input like right away. When you run this, you can enter a test word, you put another word, and finally, if you hit enter, it stops. I kind of like this structure you keep working until someone hits enter and then you stop. It's kind of an elegant way. Normally you'd say please enter word or enter to stop in parentheses to let them know. But notice it looks kind of odd, right? We didn't really want to do this part here. We didn't want to do this one final time. Does that make sense? So how do we make that better? Well, we could do it this way. This is called a priming read. So this is a priming read. And so and notice that these two are identical. So you get the input, and then while you have a word, you get words from the user, and then at some point you stop. So if you run this one, it looks a little better, right? Because you don't have the word was, and then there's nothing there. But what do we not like about this as programmers? What does dry stand for? Don't repeat yourself. Yes. So as programmers, we really don't like having this code duplicated here. And one of the reasons is, let's say you changed it, you wanted, you want to put or enter for return, and you put it in one place, but you forgot to put it in the other. Anytime we duplicate code, we increase the probability of making it harder to maintain. So you'll see this a lot in Python. While true. How many times does a while true execute? Yeah, it's always going to execute, right? So that's an infinite loop. So what makes us stop this loop? Right here. And notice we're using that break statement. So this you'll see a lot. If you need to halt, and this basically is driven because we need to halt the program in the middle. And if you run this one, it'll work elegantly, and you only have one input, and you avoid the dry problem. Does it make sense? Does it make sense online? Yeah. To me, it look, as more of a C++, C# programmer, it looks kind of odd and weird, but it works. So we went over a variety of loops. The for loop, the while loop. In Python, we really have just those two structures, which is kind of elegant, actually, not having too much. Sometimes nice in language, there's less to remember, and you just learn how to use it in different ways. And then we went over the next program. So are there any questions? Any questions online? Oh, how do you get the score? Well, basically what you're going to do is, what I'd recommend is making two variables. One would be computer score and one would be player score. And then in your if statement, when you check to see who wins, what you're going to do two things with that if statement. One is you're going to tell the user if they won or not. And then the second thing is if the user wins, you're going to increment the user wins variable. And if the computer wins, you're going to increment the computer wins variable. Then outside of that if statement, you can say the current score is, and then you have computer wins, and then you have player wins. Does that make sense, Brendan? And we're getting to the programs where they're too complex to get the whole thing in your mind, right? So if we did, actually, that's something we should discuss. If I look at this program, how can I break this up? How can I make this so that I can build it in pieces? Because there's, I always comment how there's a couple of ways you can build a program. One is write the whole thing, spend 3 days doing it, and then run it for the first time. And then, the problem is probably somewhere in this giant mass of code, or we do it in pieces. Well, we know we're going to have a do another loop, and we already did that code. Can we just grab that and get that to work? And we're going to want that loop because, in order to test this, this if statement, that'll make it easier. So maybe we write that first. And then we do know that we need to put a loop on the inside to, see if they won twice or not. But maybe the first thing you do is just get the basic logic of the game to work, right? So you ask, I would do, next thing I would do is inside of the do another loop, I'd ask the user, what their choice is, and then I would display that, make that work. Then I would probably do the random number thing, get the computer choice, and display the computer's choice, and get that to work. Now I've got the computer's choice and the player's choice. And I might just say, well, let me see if I can figure out an if statement that figures out if it's a tie, because that's pretty easy. It's if the computer's choice equals the player's choice, that's a tie. So I'll put that in there and get that to work. And then I'll say, okay, now it's reported a tie is okay. And one of the things you could do is you could test your random number generator, and testing at this point would be difficult because to get the ties, you'd have to keep running over and over and over again. I mean, within 3 or 4, you should probably get a tie, but maybe what you do is you comment out the random number generator and you hard code what the computer's choice is. So you make it pick rock so that you can pick rock with the player and make sure that you can get the ties picked up. And then you can switch the computer's choice, or you could actually ask. You could replace the random number statement with an input statement. What's the computer's choice? That way you can test it, and then you can uncomment out the random choice and comment out the input statement so that then it works randomly. So you get that working, and then you'd say, okay, well, let me figure out the conditions where the player, at least a condition where the player wins, and you write that statement. And you make that happen, and you say, okay, I can pick that up. And then you start modifying that statement so it can pick up the other conditions of the player winning. And then once you have all the player winning conditions, then you can probably say, well, the else is the computer wins. And now you've got a game playing, but it's saying do another each time. Now I think, well, okay, now I've got to keep track of the wins. So now maybe I add in a couple variables that they'll keep track of computer wins, player wins, and ties. And inside of the appropriate lines, you'll increment those, and then at the end of each loop, you just display the results. Okay, now I'm seeing the results. It's keeping track of the wins. Now I can wrap in a loop that will play until one player or the computer, either the computer or the player gets 2 wins, and now I've got the whole thing. So you see how you break it you don't do the whole thing all at once. You do a little piece at a time. If you can master that and look at a tough problem and say, what can I do first? What do I do next? What do I do next? You tend to go through the program in a straight line. You don't tend to if you find yourself backtracking a lot in your code, like you write a bunch of code, then you undo your code, then you rewrite your code, then you undo your code, then you rewrite your code. It's probably because you haven't broken the problem out in a good order to solve it. If you can break it up the right way, what happens is you solve this little problem, then you solve this little problem, then you solve this little problem, and then you're done. And that's where you want to be when you're a programmer is, no matter how big the problem is, you tend to just kind of work through it a piece at a time. Does that make sense online? Yeah, so start with the loop. Get the user input. Get the computer input. Get it to report who won. Figure out how to keep track of the total wins. And then we'll do the final loop. That's how I break it up. See you. So the rest is lab time. Okay.
Thank you.